So today we'll start discussion of week 5 classes, week 5 live classes. And in week 5, few topics regarding integration, double integration, and beta functions and gamma function was covered. So first we're gonna write the summary of the topic that has been covered in this week, and then I will be starting solving some questions which will be helpful to solve assignments in this week. So the topics that were covered in this week are first one was change of order. So change of order for double integration. Second topic was covered is change of variables. Uh, Third topic was beta function. Fourth was fourth was gamma function. And another lecture was on properties of beta function and gamma function. So this is properties of beta and gamma functions. Okay. So now we'll start solving questions from this week lectures. So the first question we're gonna see is from change of order. Okay. So and we'll shortly see what is meant by that in the question. So this is question number 1. Okay. So the question is given like this. Change the order of integration of the integral I equals to integration 0 to a integration 0 to a square minus x square to x plus 3a fxy dy dx. Okay. So here we can see that the first limit, the first limit inside the double integration is from square root of a square minus x squared to x plus 3. Correct. So that means first we have to do the integration with respect to y and then with respect to x. So now they're asking that can you change the order? So first, can you do the integration with respect to x and then with respect to y? Correct. So that means it will be like fxy dy dx, and then the limits we have to check the upper limit and lower limit of both x and the y part. Correct. So now we're gonna see the solution. Okay. So now before doing anything, first we have to draw the region in which in where we are doing the integration, like the x-axis and the y-axis, and then only we can change the order of the integration. So first try to see that here the first limit is y equals to square root of uh, y equals to square root of a square minus x square. So this is nothing but y square equals to a square minus x square, or x square plus y square equals to a square, correct? Okay. So now this is nothing but a circle centered at 0, 0 and radius a, and again y equals to x plus 3a, correct? So this is a straight line which is passing through the point 0, 3a, that is the intercept is 3a. Limit is varying from 0 to a, correct? So these are the limits of x and y are given. So now we can try to draw the region in which we are doing the integration, correct? So first try to see that x is from 0 to a, right? So this is somewhere from a comma 0, and now this is our circle, correct? So this is like the quarter of the circle, and so this is x square plus y square equals to a square. And then we have to draw the line y equals to x plus 3a. So this is gonna be somewhere here. Okay. Okay. So let us draw it here. Okay. So this is our circle, x square plus y square equals to a square. This is the line y equals to x plus 3a, and this is the line uh, x equals to a. Okay. So this is the line x equals to a. So this is the circle x square plus y square equals to a square. Okay, yeah. So now we can see that we have to do the integration in this region, correct? In this region, and so now we can try to change the order of the integration. So first we have to take a strip along x-axis. I mean, like parallel to x-axis, and then we'll see the limit of y. Now try to see that here there are three different regions, because if you try to vary the strip along in this region, and then it will not be same throughout the whole region. So that means first we have to draw the, or first we have to separate the region like this. So this is the region another, and there will be another region here. Okay, so now let us call this as I1. This is I2, and sorry, this is I3. Okay, so and then the integration I will be nothing but I1 plus I2 plus I3. That means the integration over I1 plus the integration over I2 plus the integration over I3. So now we just have to find out the integration over all these three regions, right? Correct. So first try to see in I3. So what is I3? So I3 has this region, correct? This region. So here, if you take a strip kind of like this, Then it's touching the circle, which is x square plus y square equals to a square, and the straight line x equals to a. Correct. So that means the x value is varying from uh, x equals to square root of a square minus y square to x equals to a. Okay. So here this is our x limit, square root of a square minus y square to a. And what about the y limit? So y limit will be from this point to this point, correct? So now since this is the line x equals to a, and this is the line, this is the circle x square plus y square equals to a square. So if you just put x equals to a here, so it will be y equals to 0. So y will vary from 0 to a, correct? Okay. So here the value of y will be from 0 to a, correct? So this will be 0 to a, and then fxy dx dy, correct? So this is our integration I3. Now what about I2? So for here I2, we have to take a strip here, which is parallel to x-axis. So here this strip is varying from the line y equals to x equals to 0 to x equals to a, correct? Because this line is x equals to 0 and this line is x equals to a. Okay, so x is varying from 0 to a. So now what about y? Now y is varying from here to here, correct? So here our y is nothing but 0 comma a, correct? So here y is 0 comma a, and here y should be what? Because this line is x equals to 0, correct? So that means if you just put x equals to 0 in y equals to x plus 3a, you will get 3a. So this line should be 0 comma 3a. So the limit of I2 of the region I2, the y limit should be a to 3a. Okay, and here it is varying from the region x equals to a to y equals to x equals to 0 to x equals to a, correct? So this will be fxy tx ty. Okay, so this is our region I2. Now what about I1? So for I1, see here we need to take a strip here, which is also parallel to x-axis. So here our x is y minus 3a, correct? And this side is nothing but x equals to a. So the first limit will be a to, sorry, y minus 3a to a. This is y minus 3a to a, and the x limit will be, so this line is actually x equals to a, and this line is x equals to 3a, I mean y equals to 3a. So from here to here it should be so this is 3a, and this should be if you just put x equals to a, this line should be 4a. So this should be a comma 4a, because this line is x equals to a, and if you just put x equals to a, y will be 4a, correct? And y is varying from 3a to 4a. So it should be from 3a to 4a, and then fxy dx/dy. So let me explain it again, how this integration I equals to in plus I2 plus I3 is coming. So first we try to see that we have separated the region into three regions like I1, I2, and I3. This is because the strip is not going to be same on all these three region. I mean, in all the same region. So that's why we have to make three separate region. That is in I3. Here the integration is nothing but from x equals to square root of a square minus y square to a, because this strip is going from the circle to the line x equals to a. So that's why the limit will be square root of a square minus y square to a, and the limit of y will be from 0 to a, because this is the line, this is the point 0 comma 0, and this is the line x equals to a. Now, similarly, in the region I2, the x limit is varying from the line 0 to the line a, but for y is varying from 0 comma a to 0 comma 3a, because this is the y limit. Because if you just put x equals to 0, you will get y equals to 0 plus 3a, which is nothing but 3a, correct? And similarly for the region I1, the x limit is varying from since y equals to x plus 3a, so x will be y minus 3a, and the right side is nothing but x equals to a. So the strip is varying from y minus 3a to x equals to y minus 3a to x equals to a. So this is the region of I1, and the y limit is nothing but 0 comma 3a to a comma 4a, because this line, the right side line, the rightmost line is x equals to a, and since it's touching the line y equals to x plus 3a, so you can put x equals to a there, so you will get the intersecting point as y equals to 4a. So the intersecting point of the line x plus 3a and the line x equals to a is nothing but a comma 4a, correct? So that's why the limit is from 3a to 4. So now we can write the integration I equals to 0 to a square root of a square minus x square to x plus 3a fxy dy dx equals to this is going to be integration y equals to 0 to y equals to a, and then x equals to square root of a square minus y square to x equals to a fxy dx dy plus y equals to a to y equals to 3a, 0 to a, x equals to 0 to x equals to a fxy dx dy plus integration y equals to x equals to y minus 3a, so y equals to 3a to 4a, x equals to y minus 3a to a fxy dx dy. Okay, so now if in a question fxy is given, then if you just do this evaluate these three double integration, then you will get the value of the integration of I. Okay, so we have just separated into three regions and just doing the integration on all these three separate regions. So this is how the change of order works. Okay, so I hope this question is clear. So now we're gonna go to the next question. Uh, so calculate the value of the double integral 0 to infinity 0 to infinity e to the power minus x squared plus y squared dx dy. Okay, so now I think this is one of the important questions that can be used in many form. For example, to find out the value of integration 0 to infinity e to the power minus x square dx. That's what we have seen in this week in some lecture. So so now we're gonna evaluate this integral. Now to do so, we're gonna be using polar form. Okay, so to use polar form, first try to see that the integration is performed on this region. So here this is our y-axis, and this is our x-axis, and this is the whole region. Okay, so this is the whole region. So here we have to do the integration. So to do so, first we're going to take x equals to r cos theta and y equals to r sin theta, and this will imply x square plus y square equals to r square. Okay, now since we are doing change of variables here, so we know that we have to compute the Jacobian, correct? So what is the Jacobian? Now the Jacobian is given by jxy by r theta, jxy comma r theta. So this is computed like this: del x del r, del x del theta, del y del r, del y del theta, right? So now since x equals to r cos theta, so del x del r will be simply cos theta, and since del x x equals to r cos theta, so del x del theta will be minus r sin theta. Now similarly, del y del r will be so y is r sin theta, so del y del r will be sin theta, and del y del theta will be r cos theta. Okay, and this is nothing but r cos square of theta plus r sin square of theta, which is nothing but r. Correct. So now let us draw the region again. So now we'll draw the region in polar coordinate. So this is our theta equals to 0, and this is the angle theta equals to pi by 2, and this is some point r comma theta. So this is like pr comma theta. So now try to see that in the integration it is asked that the region is varying from 0 to infinity, like x-axis is varying from 0 to infinity, and similarly y-axis is also varying from 0 to infinity, right? Correct. So that means we have to cover this whole quarter plane here. So this whole plane we have to cover using r and theta. Correct. So that means theta is varying from 0 to pi by 2. So and if you just take theta equals to 0 to theta equals to pi by 2 and vary this point p of r comma theta by taking different distances, then you can reach every point in this region, right? In this first quarter, I can go to any point. Correct. So that means that integration 0 to infinity uh, integration 0 to infinity 0 to infinity e to the power minus of x square plus y square dx dy. So this is going to change from theta equals to 0 to pi by 2, r equals to 0 to infinity, and this will be e to the power minus r cos theta square plus r sin theta square, and then we have to put our Jacobian, which is r and dr d theta. So usually the formula is like this. So if you are doing the integration over the region R, and then fxy dx dy, this is going to be over the region S in polar coordinate, in polar form, f of r theta modulus of j of xy r theta, that is the Jacobian, and then dr d theta. Okay. So here, I mean, not f of r theta. So this is like f of r cos theta, comma r sin theta, because you have to replace x by r cos theta and y by r sin theta. Correct. So that means our integration is nothing but theta equals to 0 to pi by 2, r equals to 0 to infinity, e to the power minus of r square, r dr d theta. Correct. So now we can just take r squared to be t, then 2r dr equals to dt. Correct. So our integration is changed into theta equals to 0 to theta equals to pi by 2. So now if you just put r equals to 0, this will imply t equals to 0. And if you put r equals to infinity, so this will also imply t equals to infinity. Correct. So then this limit also changed to t equals to 0 to t equals to infinity exponential minus of t, and so r dr will be dt by 2. Correct. So this will be dt by 2 and then d theta. So integration theta equals to 0 to theta equals to pi by 2. So now we know the integration of exponential of minus t dt. So which is nothing but minus e to the power minus t by 2, 0 to infinity. And then we already have d theta outside. Correct. So this is going to be theta equals to 0 to theta equals to pi by 2. So now first, if you just put theta, then exponential of minus theta is exponential of 0, so which will be 1. So this will be negative of minus 1. Correct. And then it will be minus of half, so this is minus of 1 by 2. This will be e to the power minus of infinity minus e to the power 0. Okay. So this is gonna be, and there will be a d theta. So this is theta equals to 0 to theta equals to pi by 2 minus 1 by 2. So since the exponential of minus of infinity is 0, so this will be 0 minus 1 d theta. So this is gonna be theta equals to 0 to theta equals to pi by 2 1 by 2 d theta, and this is nothing but 1 by 2 into pi by 2, so this is pi by 4. Okay, so the answer of our question should be pi by 4. Okay, so I hope this is clear, and this should be clear. This was an easy integration. So now they can ask the question like this, that what about the integration value of uh, y equals to 0 to infinity and x equals to minus infinity to infinity. exponential of minus of x square plus y square dx dy. Correct. Now similarly, you can do the same thing, right? I mean, just like drawing the region. So here Ex is varying from minus infinity to infinity. So this is somewhere minus infinity in the extended real valued system, and this is plus infinity. And Y is varying from 0 to infinity, right? So this is our 0, 0. So that means the Y will vary from 0 to plus infinity, and X will vary from minus infinity to minus plus infinity. So this is the whole region, correct? So in this case, this integration will be changing to, so since this is theta equals to 0 and this is theta equals to pi, so it will be from theta equals to 0 to theta equals to pi, r equals to 0 to infinity, and then exponential of minus of r square r dr d theta. Okay, so this should be the integration. Okay, so now similarly they can also ask this question, what about integration y equals to minus infinity to infinity, x equals to 0 to infinity, exponential minus of x square plus y square dx dy, correct? So in this case, so this is x-axis, this is y-axis. Now x is varying from minus infinity to infinity, and y is varying only from 0 to infinity, correct? So that means we have to do the integration on this region, correct? So we have to take the integration from theta equals to minus pi by 2 to theta equals to pi by 2. So this will change into theta equals to minus pi by 2 to pi by 2, and then r will be changing from 0 to infinity, and this will be e to the power minus r square r dr d theta. Okay, then this should be the answer, correct? So I hope this is clear now. Mm. Then we're going to go to the next question. So this is going to be question number 3rd. Okay, so the question is given like this: find the value of the integral zero to infinity x to the power 1 by 4 e to the power minus square root of x dx. Okay, so let me call it as 1. Okay, so we can solve this using gamma function, which has been taught in the Q course. And so let us try to see how to solve it. Okay, fine. So we know that gamma function of x is just integration 0 to infinity u to the power x minus 1 e to the power minus u and du, correct? So now to solve the question 1, so to solve 1, so somehow we're going to try to convert 1 into the gamma function in terms of gamma function or some product of gamma function such that we can evaluate the integral easily, correct? So for that reason, we're going to just put t to be root x. Okay, so if t is root x, then dt is nothing but dx by 2 root x, correct? Or dx is 2 root x dt, or 2t dt, right? So now when x equals to 0, then t is also 0, because t is just square root of x. So if you put x equals to 0, then t will be also square root of 0, which is just 0, correct? And when x equals to infinity, or x approaches infinity, then t is also approaching infinity, or just infinity. The limit is infinity. I mean, the upper limit is infinity, correct? Because t is square root of positive infinity, which is always positive infinity. So that means our integration will be changing from 0 to infinity, x to the power 1 by 4 e to the power minus square root of x dx. This is equals to, so this is going to be also from 0 to infinity. And since x is t square, so this will be t square to the power 1 by 4, and this will be to the power of minus of t, and dx will be 2t dt, correct? So 2 will go outside, this will be integration 0 to infinity t to the power 1 by 2 exponential of minus of t into t dt. So this will be integration 0 to infinity t to the power 3 by 2 exponential of minus of t dt, correct? So now try to see that to make this integration, so let us call it as 2 in the form of the gamma function, let us call it as a. We have to choose the power of t correctly, correct? So just let us write this integration as 2 integration 0 to infinity t to the power 5 by 2 minus 1 exponential of minus t dt. Okay, so now let us call this as 2. So now if you just compare 2 with a, then you can see that x is nothing but 5 by 2, correct? So if you just put x equals to 5 by 2 in a, then we are getting tau of 5 by 2, which is just the integration 2. I mean 2 times the integration 2. So this will be 2 times the gamma function of 5 by 2, correct? Now what is gamma of 5 by 2? So gamma of 5 by 2 is just 2 times 3 by 2 into gamma function of 3 by 2, correct? Similarly, 2 times 3 by 2, again this will be 1 by 2 times gamma function of 1 by 2. So 2 2 will get cancelled out, so this will be 3 by 2, and gamma of half is square root of pi, correct? So the answer should be 3 square root of pi by 2, because gamma of half is square root of pi. And this all has been derived in the due course in this respective week classes. So we can go and see the lectures. So there are all the values like gamma of 3 by 2, gamma of 5 by 2, gamma of half, gamma of 1, and all has been reduced. I mean, all has been reduced. So you can check, and you can come back to this video again. So or shortly, we are using this formula. If you want to know, the gamma of x plus 1 is x comma x. Okay. So if you just repeatedly use this formula, then you will get the value of gamma of 5 by 2. Okay. So now I think this is the answer for this question. So yeah, I hope this is clear. If it's not clear, then you can go through the video again, or maybe you can try on yourself again. And I hope this will be clear. So yeah, now we're gonna go on to the next question, which will be question number 4. Okay, so let S is the quadrant of the circle x square plus y square equals to a square, where x is greater equals to 0 and y is greater equals to 0. Then find the value of the double integral. Find the value of the uh, double integral, and the double integral is given by integration xy. I mean, this is the region x s dx dy. So the region S is given by xy such that xy x square plus y square is a square, and both x and y are positive. I mean non-negative. So now we can try to do the solution. So I think first what you have to do is draw the region S first. This is the first thing to do in double integration, so that you can you have an idea that in which region you are doing the integration. So then I can either you can do the like the order changing the order, or maybe you can change the variable sometimes if it's convenient, and then the double integration should be easier. But in this case, it's just straightforward. There is nothing to worry about it, because it's simply just x and y is a linear function in xy, correct? So this is the region. So this is x square plus y square equals to a square. So this is a comma 0. This is 0 comma a, correct? And here we are, this is the line theta equals to 0. This is theta equals to pi by 2, correct? So we'll put x equals to a cos theta and y equals to a sin theta. So this will imply x square plus y square equals to a square. Okay. So now similarly, by the argument, the previous arguments, we can change this integration in polar form like this. So this will be, so now here we can see that the theta is varying from 0 to pi by 2, and here r is varying from 0 to a, correct? So this is r equals to 0, this is r equals to 0, and this is r equals to a, correct? So this will vary from theta equals to 0 to theta equals to pi by 2, r equals to 0 to a, and x is a cos theta. Sorry, we have to put r cos theta here. R cos theta, this will be r sin theta, and then dr r times dr d theta. So here r is just the Jacobian, which you have calculated earlier, correct? So this will be x square plus y square equals to s r square. Okay. So now we have to evaluate this integration, because since we are having r, we don't need to put x equals to a cos theta or y equals to a sin theta. So we can just put r, and then we can vary r from 0 to a. So this is gonna be theta equals to 0 to pi by 2, r equals to 0 to a. So this will be r cube cos theta sin theta, cos theta sin theta r cube d theta. So now since the function f of r comma theta, which is nothing but the r cube cos theta sin theta, is separable. That means it's a product of two function in terms of r and theta. So we can do the integration separately. So first we can uh, keep cos theta and sin theta as it is, and the integration of r cube is r to the power 4 divided by 4, and this will vary from r equals to 0 to r equals to a d theta, correct? So this will be theta equals to 0 to pi by 2 cos theta sin theta, and this will be a to the power 4 divided by 4 d theta, correct? So now to write in a compact form cos theta and sin theta, we can like multiply by 2 and divide by 2, such that 2 cos theta sin theta will be sine of 2 theta, and then we can do the integration easily because we know the integration of sin theta, right? So this is going to be a to the power 4 divided by 8, theta equals to 0 to pi by 2 sine of 2 theta d theta. So here sine of 2 theta is 2 sine theta cos theta, okay? And we know that the integration of sine 2 theta will be uh, minus of cos 2 theta by 2, correct? So this will be e to the power 4 divided by 8 minus of cos 2 theta by 2, and this is theta equals to 0 to pi by 2, because sine of m theta d theta is minus of cos m theta by m, okay? So this is gonna be e to the power 4 divided by 8. So let's say if we just put theta equals to pi by 2, so then it will be 2 times pi by 2, which is just cos of pi. So it will be minus time cos of pi by 2, and minus minus plus cos of 0 by 2, correct? So this is a to the power 4 by 8. Now cos pi is minus 1, so it will be plus 1. So it will be 1 by 2, and cos 0 is also 1. So this is 1 by 2. So since 1 plus 1 by 2 plus 1 by 2 is 1, so this is going to be just a to the power 4 divided by 8. So this should be the answer, because here uh, cos of pi is minus 1 and cos of 0 is 1. Okay. So yeah, I hope this is clear now. And so this will be the answer. So it was question number 4. Now uh, we're gonna go to the question number 5. Okay. So now this is regarding beta function. So it says like this: find the value of the exponential, sorry, of the expression beta of 7 by 2 comma minus 1 by 2. Okay. So this is beta of 7 by 2 comma minus 1 by 2. Solution. Yeah, so I think many of you can guess the answer, or maybe you can easily find out the answer. So the beta function, I think we know there is a formula, or there is a connection between beta function and gamma function. So it goes like this, that beta of m comma n is gamma of n into gamma of n divided by gamma of m plus n. Correct. Now by that formula, we can write beta of 7 by 2 comma minus 1 by 2 as gamma of 7 by 2 gamma of minus 1 by 2 and then gamma of 7 by 2 minus 1 by 2. So this is gonna be gamma of 7 by 2 gamma of minus 1 by 2 and this will be gamma of 3. Correct. Okay, so now we have to find the value of gamma of 7 by 2 gamma of minus 1 by 2 and gamma of 3. Now gamma of 3 is easy because we know that gamma of m plus 1 is m gamma n, and then you can repeat the process and then eventually you can find out that gamma of m plus 1 is nothing but m factorial. So in this case, gamma of 3 will be 2 factorial. Okay. So now gamma of 7 by 2, this is gonna be, so we can write like this, gamma of 1 plus 7 by 2 minus 1, correct? Or 7 by 2 minus 1 plus 1, and then 7 by 2 minus 1 gamma of 7 by 2 minus 1. So this is gonna be 5 by 2 into gamma of 5 by 2, and then we can repeat the process. So this will be 5 by 2 into 3 by 2 into gamma of 3 by 2, and then 5 by 2 into 3 by 2 into 1 by 2 into gamma of 1 by 2, and gamma of 1 by 2 is root pi. So this will be 15 divided by 8 into root pi, as gamma of 1 by 2 is root pi. Correct. Now what about gamma of minus half? So we have to try to find what is the value of gamma of minus half. Correct. So to do so, we have to use another formula which is called the complement formula, and it is written like this. So the complement formula, so it is written like this. Gamma of x into gamma of 1 minus x is same as pi divided by sine of pi x. Okay, so now since we need gamma of minus half, so we can put x equals to half, so such that gamma of x, like gamma of 1 minus x will be minus of half, or we can put also x equals to no, I think x is positive, so we have to put x equals to half. So if you just put x equals to half, yeah, sorry, I think we have to put x equals to minus half, not x equals to 3 by 2, because if you just put x equals to half, this will be 1 minus 1 by 2, so just 1 by 2. So that's why you have to put x equals to 3 by 2. So this will be gamma of 3 by 2 to gamma of 1 minus 3 by 2, and this is gonna be pi times sine of 3 pi by 2. So this will be gamma of 3 by 2 gamma of minus 1 by 2. So we know that sine of 3 pi by 2 is just sine of pi plus pi by 2, correct? And sine of pi by plus pi by 2 is nothing but cos of pi by 2, which is 1, correct? sorry. So this is gonna be pi times sine of pi plus pi by 2, or gamma of minus half. This is gonna be minus of pi times, because sine 3 pi by 2 is minus 1, and this will be sine of minus of sine of pi by 2. So this will be minus of 1, and this is gamma of 3 by 2. Okay, so this is gonna be minus of pi times 1 by 2 into root pi. So this will be minus of 2 root pi. Okay, because gamma of 3 by 2 is 1 by 2 times gamma of 1 by 2, which is 1 by 2 times root pi, or root pi by 2. Okay, so now we can put all the values together, and then we can see that beta of 7 by 2 comma minus 1 by 2 is gamma of 7 by 2 gamma of minus 1 by 2 divided by gamma of 3. So this is 15 square root of pi divided by 8 into minus 2 root of pi divided by 2. So this get cancelled out, and this is minus 15 pi divided by 8. So this should be the answer. Okay, so I hope this is clear now. Okay, so now if you have any doubts, then I can go through the video again, or otherwise you can always ask me in the next class. So please go through the properties of beta and gamma function, so that it will be easy for you to understand the concepts, and eventually solve some questions. Okay, so now we're gonna go to the next question, which is question number 6. Okay, so using substitution x plus y equals to u, and y equals to uv, find the value of the integral xy times 1 minus x minus y square root of to the power 1 by 2 dx dy. Okay, where delta is bounded by the lines x equals to 0, y equals to 0, and x plus y equals to 1. Okay, so I think this is a good question, and this is a lengthy question as well. So yeah, I will try to see how it's going. So first, the first and foremost task is to just draw the region delta here. So this is gonna be uh, a triangle. So this is our x equals to 0 line. This is the line sorry, this is the line y equals to 0, this is line x equals to 0, this line x plus y equals to 1. These are the intercepting point 1 comma 0, and this is 0 comma 1. Okay, so it is given that x plus y equals to u and y equals to uv. So x plus y equals to u, this will imply x equals to u minus y. Now y is uv, right? So this will be u minus of uv, or u times 1 minus p, and y is given by uv. Okay, so now we'll calculate the Jacobian. Since we are doing change of variables, so we have to calculate the Jacobian. So our Jacobian will be j of xy by uv. So this is gonna be del x del u, del x del v, del y del u, del y del v. Correct. So del x del u is just 1 minus p. Del x del v is minus of u. Similarly, del y del u is v, and del y del v is u. So del x del u here will be 1 minus p. Del x del v is minus of u, and del y del u is v, and del y del v is u. So now we have to just find out the determinant of this matrix. So this is gonna be u times 1 minus p plus uv. So this is u minus uv plus uv. Correct? So this should be u. Okay. But the value of the function actually, this which is xy times 1 minus x minus y. So this will be u times 1 minus p into uv into 1 minus u times 1 minus p minus of uv, right? So this is gonna be u times 1 minus p. So like u square of v, 1 minus of v, and this will be 1 minus of u plus of uv minus of uv, right? So this will be u square of v, 1 minus v into 1 minus u. Correct? So now we have to see the limit of the function. Correct? So for that reason, try to see that if x is 0, then u times 1 minus p is 0. So this will imply either u is 0 or p is 1. Now similarly, if you just put y equals to 0, so this will imply uv is 0. Correct? So now we have two choices, either u is 0 or v is 0. And similarly, if you x plus y is 1, then u is 1. So our limit will be 0 less equals to u less equals to 1, and 0 less equals to v less equals to 1. Correct? So then our integration will be changed onto this dx, and then u times du dv. Correct? So now since the function is separable in both u and v, so we can make it simplify, and then we can do the integration first with respect to u and then with respect to v. So this is gonna be integration v equals to 0 to 1, a equals to 0 to 1. This will be u square of square root of v into uh, u square into square root of 1 minus v into square root of 1 minus u 1 minus u, then du dv. Okay, so now we can do the integration with respect to u first. So this will be v equals to 0 to 1 square root of v square root of 1 minus v integration equals to 0 to 1 u square square root of 1 minus u du and then dv. Okay, so now we have to evaluate this integration equals to 0 to 1 u squared times square root of 1 minus u du. So now try to see that if you just put u equals to uh, or u square equals to t, uh, sorry, 1 minus u equals to t, then minus of du will be dt. And then, so this is u, this is t. So now if you just put u equals to 0, then t will be 1. And if you put u equals to 1, and then t will be 0. So this integration will change from t equals to 1 to 0. So u square will be, so from here u is 1 minus t. So this will be 1 minus t square square root of t dt. Sorry, minus of dt. Correct. Now since the limit is from 1 to 0 and there is a negative sign here, so we can interchange this. So it will be t from 0 to 1, 1 minus t square square root of t dt. And this is because integration a to b fx dx equals to minus of integration b to a fx dx. Correct. This always hold for definite integrals. So it will be integration 0 to 1 1 minus 2t plus t square into square root of t dt. Correct. So now we can multiply square root of t. So this will be root t minus 2t to the power 3 by 2 plus t to the power 5 by 2 dt. Correct. So this integration is gonna be t to the power 3 by 2 divided by 3 by 2 minus 2 to the power 5 by 2 divided by 5 by 2 plus t to the power 7 by 2 divided by 7 by 2 and integration 0 to 1. So this is gonna be 2 by 3 minus of 4 by 5 plus 2 by 7. Correct. So this is gonna be 3 into 5 into 7. So this will be 70 minus 84 plus 30. So this is 16 divided by 105. Okay. So our integration value is 16 divided by 105 integration 0 to 1 square root of b to square root of 1 minus b dv. Okay. So now this can be solved by, sorry. So now this can be solved using beta function because this is just 16 divided by 205 integration 0 to 1 v to the power 3 by 2 minus 1 into 1 minus v to the power 3 by 2 minus 1 dv, right? So this is just 16 by 205 beta of 3 by 2 comma 3 by 2, because beta of mn is integration 0 to 1 x to the power m minus 1 1 minus x to the power 1 minus n minus 1 dx, correct? So this is gonna be 16 by 205 comma of 3 by 2 comma of 3 by 2 divided by comma of 3 by 2 plus 3 by 2, because beta of m comma m is comma of m into comma of m comma of m into comma of m by comma of 2m, correct? So this is gonna be 16 divided by 205 and comma of 3 by 2 whole square, and this is gonna be comma of 3, correct? So uh, we know that comma of 3 by 2 is just 1 by root pi, correct? So this integration is gonna be 16 divided by 205 multiplied by root pi by 2 square divided by 2 factorial, correct? So this is 16 divided by 205 into pi divided by 4 into 1 by 2 factorial. So this will be 16 pi by 205 into 8. So the answer should be 2 pi divided by, so sorry, this is 105, not 205. Okay, so this will be 105. So this will be 2 pi divided by 105. Okay, so this should be the answer. Now there is a short form for this integration to evaluate in terms of gamma function. So I'm gonna write this as a remark. So if someone asks you for evaluating the integration of this triple integration, like x greater equals to 0, y greater equals to 0, z greater equals to 0, and x plus y plus z equals to 1, and then x to the power alpha minus 1, y to the power beta minus 1, and z to the power gamma minus 1, f of uh, x plus y plus z, tx, ty, tz. This is gonna be gamma of alpha times gamma of beta times gamma function of gamma divided by gamma of alpha plus beta plus gamma. Okay, so this is just the direct formula to compute this integration. Okay, so now we're gonna go to the next question. So find the value of beta of m comma m into beta of m plus 1 by 2 comma m plus 1 by 2. Okay, so solution. So now try to see that that beta of m comma m is gamma m square divided by gamma of 2m, and beta of m plus 1 by 2 comma m plus 1 by 2 is beta of m plus 1 by 2 square divided by gamma of m plus 1 by 2 square divided by gamma of 2m plus 1, and which is same as gamma of m plus 1 by 2 square 2m gamma of 2m. So beta of m comma m into beta of m plus half comma m plus half. So this is gamma m square, or gamma m into gamma of m plus 1 by 2 divided by gamma of 2m square into 1 by 2m. Correct. So uh, now by Legendre duplication formula, we have gamma of m times gamma of m plus 1 by 2. This is same as square root of pi divided by 2 to the power 2m minus 1 gamma of 2m, or in other words gamma of m into gamma of m plus 1 by 2 divided by gamma of 2m equals to square root of pi divided by 2 to the power 2m minus 1. So beta of m comma m into beta of m plus 1 by 2 comma m plus 1 by 2, this is going to be square root of pi divided by 2 to the power 2m minus 1 square into 1 by 2 to the power 2m. Correct. So this is pi divided by so sorry, this is 1 by 2m. Correct. So this is 2 to the power 4m minus 2 into 1 by 2m. So this is pi divided by 2 to the power 4m minus 1 into 1 by m. So beta of m comma m into beta of m plus 1 by 2 comma m plus 1 by 2 is pi divided by 2 to the power 4m minus 1 into 1 by m. So this should be the answer. Okay. So I hope this is clear. So now we're going to go to the next question, which is question number 8. Okay. So it is given like this. Find beta of m comma 1 by 2 to beta of m plus 1 by 2 comma 1 by 2. Solution. So beta of m comma 1 by 2 is just gamma m into gamma of 1 by 2 into gamma of m plus 1 by 2, correct? So this is just gamma m into root pi divided by gamma of m plus 1 by 2. Now similarly, beta of m plus 1 by 2 comma 1 by 2 is gamma of m plus 1 by 2 into gamma of 1 by 2 divided by gamma of m plus 1, correct? So this is gonna be gamma of m plus 1 by 2 into square root of pi divided by m gamma m. So hence beta of m comma 1 by 2 into beta of m plus 1 by 2 comma 1 by 2. So this is gonna be gamma m root pi divided by gamma of m plus 1 by 2 multiplied by gamma of m plus 1 by 2 into root pi divided by m gamma m. So this gamma m got cancelled out. Gamma of m plus 1 by 2 and gamma of m plus 1 by 2 got cancelled out. So we have only pi divided by m. So beta of m comma 1 by 2 to beta of m plus 1 by 2 comma 1 by 2 should be pi divided by m. Okay. So this is the answer. So if you have any doubts, please go through the video, and then if you have any other doubts, then you can ask me in the next class. Okay. So now we're gonna go to the next question. So find the value of the integration 0 to 1 x to the power 4 log of 1 by x cube dx. Okay. So this is solution. Okay. So first, what you're gonna do is we're gonna substitute x to the power 4 by e to the power minus of t, and then we're gonna change it to a gamma function, some product of gamma functions. Then we can evaluate it easily. Correct. So substitute x to the power 4 equals to e to the power of minus t, right? So this is implying that e to the power of t is 1 by x to the power 4, correct? Or x is e to the power minus of t by 4 and this is implying that dx equals to minus of 1 by 4 e to the power minus t by 4 dt. Okay. And also from here uh, t equals to minus of 4 log x. Okay. So now the limit is given from 0 to 1. So when x equals to 0, then so if you just put x equals to 0, then you can see that t is actually plus infinity, correct? Because log of 0 will be minus infinity, and minus times 4 times log plus infinity minus infinity will be plus infinity. So this will be plus infinity. And when x goes to 1, then log 1 is 0, so t will be 0. Correct? So the integration will change from 0 to 1, x to the power 4 log of 1 by x cube dx. So this is equals to infinity to 0. So x to the power 4 will be e to the power of minus of t, and log of 1 by x will be so x is e to the power minus of t by 4. Correct? So this will be e to the power t by 4 log of e to the power t by 4 cube, and dx is minus 1 by 4. This is multiply e to the power minus of t by 4 dt. Okay, so this is going to be from, so since there is a minus, so this will be from 0 to infinity, and then 1 by 4 is going outside, so this will be exponential of minus of t. Okay, and this is going to be sorry, this is going to be exponential of minus of 5t by 4, and this will be t by 4 whole cube dt. Okay, so now we can just substitute 5t by 4 to be u. So so this will be 4. So this is implying t equals to 4u by 5. Correct? Or dt equals to 4 by 5 tu. So similarly, if you just put t equals to 0, u will be 0, and if you put t equals to infinity, u will be infinity. So this is 1 by 4, 0 to infinity, e to the power of minus of u. So t by 4 is u by 5, so this will be u by 5 whole cube, and dt is 4 by 5 du. Correct? So this is so this 4 will get cancelled out, so this will be 1 by 5 to the power 4, 0 to infinity, e cube e to the power minus u du. Correct? So this is same as 1 by 6 to 5 integration 0 to infinity. So this is u to the power 4 minus 1 e to the power of minus u du. Now this is same as 1 by 6 to 5 gamma of 4, and gamma of 4 is nothing but 3 factorial. Correct? So this is 6 to 5 into 3 factorial. So the answer should be, sorry, 3 factorial divided by 6 to 5. So it should be 6 divided by 6 to 5, and this is the answer. Okay, so I hope this is clear now. So basically you have to just substitute x to the power 4 by exponential of minus t, and then you have to write x in terms of t. Then just you have to find the dx, and then just if you substitute all the values, then it will change into the integration 1 by 4 0 to infinity exponential minus of 5t by 4 uh, t by 4 whole cube dt. So then we can substitute 5t by 4 by u, and then it will be changed into a gamma function. Okay, some constant multiplied of gamma function, and the answer is nothing but 3 factorial divided by 6 to 5, or 6 by 6 to 5. So this should be the answer. Okay, so now let us go on to the next question. So calculate the value of integration 0 to 1 x to the power 3 by 2 1 minus square root of x 1 by 2 dx. Okay, so now first what you're going to do is we're going to do some substitution, and then we'll try to change into a beta function, because we can see that there is some similarity between beta function, but it's not in the actual form of beta function. And then after the substitution, then we can check that it will be changed into a some beta of m comma n for some values of mn, and then we can easily evaluate that in terms of gamma function, right? So try to see that beta of mn is integration 0 to 1 x to the power m minus 1 1 minus x to the power n minus 1 dx, right? So to get in this form, substitute root x equals to t in 1. Okay, so then x equals to t square and dx is 2t dt, right? So now if you just put x equals to 0, t will be 0, and if you put x equals to 1, then t will be also 1. So our integration 0 to 1 x to the power 3 by 2 1 minus square root of x to the power 1 by 2 dx. This is changed into integration 0 to 1. So x is t square, and so this is going to be t cube 1 minus of t to the power 1 by 2. This will be 2t dt. Thus 2 times 0 to 1 to the power 4 1 minus t to the power 1 by 2 dt. Correct? So now we can write it in terms of to compare with the with the beta function. So like t to the power 5 minus 1 1 minus t, and this is 3 by 2 minus 1 dt. Correct? So now we can compare 2 with a. Now comparing 2 with a gives, so this will give integration 0 to 1 x to the power 3 by 2 1 minus root x to the power 1 by 2 dx equals to 2 times beta of 5 comma 3 by 2. So now just we have to evaluate the beta of 5 comma 3 by 2, then we'll get the answer, right? And we know that beta of m comma n is gamma m into gamma n divided by gamma of m plus n. Correct? So this will be 2 times gamma of 5 into gamma of 3 by 2 divided by gamma of 5 plus 3 by 2, right? And gamma of 5 is 4 factorial, so 2 times 4 factorial, and gamma of 3 by 2 is so I think we can keep gamma of 3 by 2 because it will get cancelled out. Gamma of 3 by 2 divided by gamma of 13 by 2. So this is gonna be 2 times 4 factorial into gamma of 3 by 2 divided by 13 by 2 into, sorry, 11 by 2 into gamma of 11 by 2, then 9 by 2 into gamma of 9 by 2, 7 by 2, 5 by 2, 3 by 2, and gamma of 3 by 2. correct? So this two will cancel out. So this is gonna be 2 times 24 uh, divided by 11 into 9 into 7 into 5 into 3 divided by 2 to the power 5. Okay, so this should be 64 multiplied by 24 divided by 3 into 5 into 7 into 9 into 11. So 3 and it goes 8, and I don't think anything will get cancelled out here. So this should be 512 divided by so 35 multiplied by 11 is 385. Multiplied by 9 will be 514, 5, 6, and this will be 3, 4. Correct? So it should be 3, 4, 6, 5. So this should be the answer. Okay. So I hope this is clear now. Okay. So also we can do using the polar form. I mean the polar form of the beta function. So we can do that easily. So just substitute x equals to sine to the power 4 theta. Okay. So then dx will be 4 sine q theta cos theta d theta. So if x equals to 0, then theta is also 0, and if x equals to 1, then sine theta cos sine q theta cos theta will be 1. So that means theta will be pi by 2. Correct? I mean, sorry, sine for theta will be 1 and theta will be pi by 2. So our integration 0 to 1 x to the power 3 by 2, 1 minus square root of x to the power 1 by 2 dx, and this is gonna be 4 times integration 0 to pi by 2, and we are putting x to be sine 4 theta, and it is given by x to the power 3 by 2, so it should be sine to the power 6 theta, and then 1 minus sine square of theta to the power 1 by 2, and then sine q of theta cos theta d theta. So this should be integration 0 to pi by 2 sine to the power 9 theta. It should be cos square of theta d theta, right? So this is 0 to pi by 2 sine to the power 2 times 5 minus 1 theta into cos to the power 2 into 3 by 2 minus 1 theta d theta. Correct? So this is gonna be 2 times 2 integration 0 to pi by 2 sine to the power 2 minus 5 minus 1 theta cos to the power 2 multiplied by 3 by 2 minus 1 theta d theta. And this is just 2 times beta of 5 comma 3 by 2. Correct? So this is because 2 time integration 0 to pi by 2 sine to the power 2m minus 1 theta cos to the power 2n minus 1 theta is same as beta of, so there should be a d theta, same as beta of m comma n. And this is also how we can evaluate this integration. Okay, so I hope this is clear. So this was question number 10. So now go to the next question, which is question number 11. Okay, find the value of the integral uh, 0 to 1 x to 1 sine of y square dy dx. Okay, so first we're going to draw the region where we are performing the integration, and then we will try to see how to do the integration. Correct. So y is varying from x to 1. So this is the line y equals to x. Correct. And this is the line y equals to 1. And x is also varying from 0 to 1. So this is our line x equals to 1. Okay. So x is from 0 to 1 and y is from x to 1. So that means this should be the region, because they have taken the strip like this. That's why y is varying from x to 1. Okay. So what you're going to do is we're going to change the order of the integration so that it would be easy to find out the value, right? So what you're going to do is we're going to take a strip from here to here. Okay. So this is going to be x equals to 0 to x equals to y, and then y will vary from 0 to 1. This is 0 comma 1. This is 0 comma 1. Correct. So this is 0 comma 1. So y will vary from 0 to 1. This will be sine of y square dx dy. So let us call it as I. So this will be our I. So this is just 0 to 1 sine of y square x equals to so this will be x equals to 0 to y, and then dy. So this is y equals to 0 to 1. So this will be y sine y square dy. Okay. So we can just put y square to be z, and then 2y dy is dz, or dy is dz by 2y. Correct. Or dz by 2 root z. So similarly, the limit will be also from 0 to 1. Y is root z sine z, and then this is dz by 2 root z dz. So our integration changes to integration 0 to 1 1 by 2 integration 0 to 1 sine z dz. Correct. So this will be minus of 1 by 2 cos z 0 to 1. So this is gonna be minus of 1 by 2 cos of 1 minus cos of 0, or in other words minus 1 by 2 cos of 1 minus 1, or we can write it as 1 minus cos of 1 divided by 2. So for this question our answer is cos of 1 by 2, 1 minus cos of 1 by 2. So I hope this is clear now. So now let us solve the next question, which is question number 13. Sorry, question number 12. Solve integration 0 to 1 x to 1 e to the power y square dy dx. So now this is also a similar question like the previous one, and this is just gonna be the same region, correct? So this is y equals to x, and this is y equals to 1, and then this is x equals to 1. So let us call this as I. So I is gonna be changing to, so we have to take a strip like this. So this will be from 0 to 1. So this is x is gonna be from 0 to y, and then exponential of y square dx dy. So this is same as y exponential of y square dy. So now if you just do the integration, you'll get half 2y exponential of y square dy. So this is going to be half of integration 0 to 1 d of y square. So this is half of y square 0 to 1, and this is half of e minus 1. So this is the answer. So yeah, let us solve the next question. So this is gonna be question number 13. And so question is given like this: change the order of the integration and evaluate it. So the integration is given like this: I equals to integration 0 to a y to a x divided by x square plus y square dx dy. Okay. Now we're gonna draw the region in which we are doing the integration, and then we'll change the order, and then we'll try to evaluate the value of the integration. Okay. So here see that x is varying from y to a, and y is varying from 0 to a. Okay. So this is x equals to y. So this line is x equals to y, and this line is x equals to a. So this is x equals to a, and this point is a comma a. Okay, so x is varying from y to a. So this is like this. So they have given this strip, and y is varying from 0 to a. So now we can take a vertical strip like this. Okay, so our integration I will be changed into. So first we have to take the limit of uh, y and then the limit of x. So the limit of y will be 0 to x, and then the limit of x will be 0 to a. So this line, and then x divided by x square plus y square, and then dy dx. Okay, so now if you just evaluate this integration, then we'll get the get the integral value y. Okay, so now first we will do the integration with respect to y. So that means integration 0 to a. This is 0 to x. This is x, and this will be 1 divided by x square plus y square dy, or maybe we can take x outside, and this will be dx. So now uh, this is same as tan inverse of y by x, 0 to x, and there will be another 1 by x dx. Okay, so this is gonna be 0 to a. So if you just put y equals to x, then this will be tan inverse of 1. So 1 by x times pi by 4 minus 1 by x times tan inverse of 0, which is 0. So this will be pi by 4, 0 to a dx, which is same as uh, pi a by 4. So this should be the answer of this question. Okay. Okay. So let us write the next question, which is question number 14. Now this is regarding beta function. So evaluate integration 0 to pi by 2 sine to the power 6 theta cos to the power 4 theta d theta. Okay. So now one thing to notice is that uh, integration 0 to pi by 2 uh, sine to the power m minus 1 theta cos to the power n minus 1 theta d theta. This is same as beta function of m by 2 comma n by 2. So now we can write 0 to pi by 2 sine to the power 6 theta uh, cos to the power 4 theta d theta as integration 0 to pi by 2 sine to the power 7 minus 1 theta and cos to the power 5 minus 1 theta d theta. So this is gonna be half times beta of 7 by 2 comma 5 by 2. So this should be the answer, and even we can evaluate this also. So this is gonna be half times gamma of 7 by 2 to gamma of 5 by 2 gamma of 7 by 2 plus 5 by 2. So this is half times 5 by 2 into 3 by 2 to 1 by 2 into gamma of half into 3 by 2 1 by 2 into comma of 2. Now 7 by 2 plus 5 by 2 is 12 by 2, so that is comma of 6, and comma of 6 is 5 factorial. So this is going to be 5 factorial. So half multiplied by, so this will be 15 by 4 into 3 by 4 into 1 by 2 into pi divided by 5 factorial. Okay, so this is going to be 15 into 3 into pi divided by 64 into 5 factorial, correct? So 5 factorial is 5 into 4 into 3 into 2 into 1. So 15 will get cancelled out, and from here we'll get only 2 times 4. So 3 pi divided by 64 into 2 into 4. So this should be 3 pi divided by 512. Okay, and this should be the answer. Okay, so now let us go to the next question, which is question number 15. Evaluate integration 0 to infinity x to the power a minus 1 divided by 1 plus x to the power a plus b dx, where a and b are greater than 0. Okay, so now what you're gonna do is we're gonna substitute x by t into 1 minus t. So then dx, sorry, then 1 plus x will be t divided by 1 minus t plus 1. So this is gonna be 1 divided by 1 minus t. Okay, and dx is gonna be 1 minus t square, 1 minus t minus t times minus of 1. So t will get cancelled out, 1 minus t plus t divided by minus t square. There will be another dt here. So this is gonna be 1 divided by 1 minus t square dt. Okay, so this integration. So now if you just put x equals to 0 as then so also x equals to t divided by 1 minus t. This is implying x into 1 minus t equals to t, or in other words t time 1 plus x equals to x, or t equals to x by 1 plus x. So if you just put x equals to 0, then t will be 0, and if you put x equals to infinity, then t will be 1, correct? So our integration now will be changing from 0 to 1, and t by 1 minus t to the power a minus 1 divided by 1 by 1 minus t to the power a plus b. And dx is 1 by 1 minus t square dt, correct? So this is integration 0 to 1 t to the power a minus 1 divided by 1 minus t to the power a minus 1 into 1 minus t to the power a plus b into 1 by 1 minus t square dt. Okay, so this will be integration 0 to 1 t to the power a minus 1 1 minus t to the power a plus b minus 2 minus a plus 1 dt. So this is integration 0 to 1 t to the power a minus 1 1 minus a, and this is p minus 1 dt, and this is just beta of a comma b. Okay, so this should be our answer to this question. Now I hope this is clear, and if there is any doubt, please go through the video again. So yeah, I think this 15 questions should be enough for this week to solve those assignment problems.